What's up, calculus students? I'm going to do a video for your quiz 74 in case you want to go through it and check your work. So let's go. My cursor's in and out, so I might have to unplug and plug back in, but we'll figure it out. Okay, so the first question assumes that you don't have a calculator. Okay, now you can check your work with a calculator. I can't stop you from, but for your free response test, you need to show all of your work without a calculator. Okay, so first question is, here's a position function. When is the particle furthest to the right on the interval from t equals 0 to t equals 3? Okay. Furthest right means we are talking about a max of position. All right. To find a max of something, you should take the derivative of that thing, set it equal to 0. So I want to look at x prime, and that's 2t minus 5. And I set that equal to 0. I easily get t equals 5/2. Now, it's important to realize that x prime is v. So when you do your sign analysis, you should kind of know like what this is telling you. So I plop down 5/2 between 0 and 3. I do a sign analysis. I have positives and negatives. Okay. Now this is x prime. This is telling me x is going down then going up, or position is decreasing then increasing, or my velocity is negative then positive. Velocity being negative means I move to the left and then I move to the right. So if you move to the left and then move to the right, obviously this will be when you're furthest left. One of these 2 points is when you're furthest right. It's going to be one of our endpoints. Now the only way I know if it's going to be 0 or 3 is to check. We can't assume based on intervals that one's going to be bigger than the other. You need to go ahead and compare the actual positions. Now, not the derivatives of positions, but the actual original positions. And if I plug in 0, I get 6. And if I plug in 3, I get 9 minus 15 plus 6, which is 0. So what is my max position when t equals 0 and I have a position of 6? You would have to show all this work, and you'd have to show the checking of your endpoints to get full credit. Next question is, when is the particle furthest left? I'm going to keep this work up here because all I'm going to do now is find a min position. Well, I know when my min position is going to occur. I move from 0 to the left and then to the right. So when I stopped moving left and start moving right here, that's when I'm going to be at a min position. You don't have to do any work here. If you've shown all this work, this is what you would want. You'd answer t equals 5/2. What I would not accept is anybody like graphing position on a calculator and saying, here's the answer without showing all of this work. Okay? So that answers the first 2 parts. Next question. Let's find the average position. Average position. So average is not like the average you think, okay? I like to explain this starting with average velocity. Okay, we know slopes of position gives us velocity, and average velocity is the change in position over the change in time. I'll use like x of b, but think of that as like the end minus the start over the end minus start time, okay? But we also know that this is equal to the area under the velocity from the start to the end. Like to evaluate the area under velocity, you take the antiderivative, plug in b, plug in a. Well, how does that help me? We typically won't use this to find an average of something. We will use this. And notice v, the area under v, helps us find the average v. So if I want to find the average x, I'm not going to plug in values into x. I'm going to find the area under x and then multiply by that by 1/3, that 1 over b minus a. This is the average x. Now, how do you find this without a calculator? You can't plug this in and get a number. I would not accept that as full credit, okay? you know that it's like, oh, okay, to find this, I'm going to not think of this as area, but think of this as more of the instructions of what to do. Take the antiderivative, plug in 3, plug in 0. So 1/3 times 1/3 t cubed is the antiderivative of t squared. 5/2 t squared is the antiderivative of 5t. And then 6t plus c. I don't need the plus c because I'm going to be subtracting these things when 3 and 0 are plugged in. I get 1/3. This is 23, 9, 27 divided by 3 is 9, minus 45 halves plus 18. Subtract 0 plugged in. And I get 1/3. This is 27 minus 45 halves. This is 54 halves minus 45 halves. This is 9 halves. And my answer is 9/6, which is 3 halves. Okay, now that's the average. I would probably recommend, since you do have access to a calculator, I can't stop you, go ahead and check. Okay. Type into your calculator 1/3 math 9 area from 0 to 3. Now, this is only to check. You have to show all your work, or I will not give you all credit. And make sure you get that 3 halves. Okay, which you do. All right. Next part. New question. Assume you do have a calculator. Cool. You have a velocity given like this. You're given an initial position. When is the particle furthest right from 0 to 10 and what its location? Justify your answer using calculus. Okay, particle furthest right. That's going to be a max of position. Okay, a max of position could occur when its derivative equals 0 or an endpoint. Well, I'm not going to take the derivative of velocity here because the derivative of position is what I want. The derivative of position is velocity. So actually, I need to go ahead and figure out when this crosses 0, when this equals 0. I could try to solve that by hand, but that's going to be messy. So this is when I'm going to use my calculator. I'm going to figure out when does v equal 0. So break out your calculator. Let's do some work here. I'm going to graph 10 sine. I'm going to make sure my calculator is in radian mode. X squared over 10. I'm looking from 0 to 10, so that's nice. I don't have to adjust my window too much. Maybe I adjust my y's a little bit, but whatever. Don't forget to plug in 0. I think it's easier to find zeros when you have y equals 0 plugged in. Okay, so here, fantastic. 1, 2, 3 zeros. All right, so I'm going to find the locations of those zeros. I'm going to plot them on a number line to make sure I understand what I've just found. So I got 5.6, this number. I should write it down because I might use it again. I got 7.92. And I have 9.708. Okay, now I notice my velocity values, my x prime values, my velocity values are positive, then negative, then positive, then negative, okay, between 0 and 10. This is telling me I'm moving right, then left, then right, then left. So the questions are, where could we have a possible max? Well, if you move right, then left, then right, then left, I know for a fact it's not going to be an endpoint because this is going to be further right than wherever I started here. I know it's not going to be 10 because I'm going from the left from 9.7 to 10. So I really have two candidates, this guy and this guy. Those are my two possible maxes. The other ones just won't make sense because it's further to the left than those positions at those times. But now, how do I know which one is going to be the max? This is where we have to check. So, like, how do I find the position x of 5.6049912? Now, I'm going to show you a little quick secret here. You either have that number written down fully, or let's go back and find this intersection. And what happens is that this number gets stored as x. Okay, so right now, after you find the intersection, that number is stored as x. If I go back into my home screen, if I plug in x, I get that number. Okay, now how do I find this position? Well, I could try to take the antiderivative of this and then find c and find a position function, but I can't. I can't take the antiderivative of this. So this is where we do the whole end position equals our start position plus our displacement. Well, my starting position, x of 0, I know is 4. My displacement can be found by finding the area under my velocity from 0 to that 5.6 number. Now, you got to use that entire number in your integral of your v. This is what I need to type into my calculator. I need 4 plus, now watch this, math 9. You can go from 0 to x. Now, this x acts as a number. It comes in as this number. But then when you use x inside your integral, it's acting like a variable. So it's a little bit confusing, and I don't want us to, if we're not sure about this, don't do it. But we get a position of 32.297. Uh, 297. Now, you could have done the same thing, but instead of this x here, you could have typed in the entire number, 5.6049912. Okay? But I need to compare that to my position at 9.708126. Now, again, I can go back to my graph and find this intersection and just use that number in my integral, or if you wrote it down, then it's fine. Enter, enter, enter. So 9.708126, okay? Again, equals a starting plus a displacement between the start and the end. So I'm going to use the same integral, but now x is stored as the 9 number. I'll show you that. I get 28.926. 28.926. Dot, dot, dot. But if you aren't comfortable doing that, or if you forget to find the intersection, you can use this number, 9.708126. Boom. You get that same number, okay? So what is my max position? My max position is here, here. This would be proper justification that I'd want to see. You're identifying your candidates, you're checking your positions, you then saying, okay, this is when we are furthest right, and that's its location. When are we furthest left? Okay, well, if I want to know when I'm furthest left, now we need to find a min of position. Well, I have all this work up, which is great. Because if our maxes are potentially here, our mins could be here, here, or here. Because I go to the right, then I go to the left here, then I go to the right, then I go to the left. So you just have to do a little bit of work. We already know x of 0 is 4. Okay, let's find x at that 7.92 number. It'll be the start plus your displacement. And I'm plugging in 0 here because my starting is at t equals 0. And then I'll also find the x of 10 number. This is easy to plug in, 0 to 10 of v. So let's find the x of 10 number first. I got 28.11. That obviously is not the min. I'm thinking this could be the min, but let's figure out what's going on at 7.92. I have the number 9266546. Since I wrote it down, I might as well just like use it again. Start plus displacement from 0 to that of v. 4 plus, oh, I have it up here. 7.9266546. I get 17.61. That loses as well. Six one zero. Not smaller than this. X of 0, my starting position is actually when I'm furthest left. Now, if you look at the graph of velocity, you can kind of tell that, but that would not be proper calculus justification. Remember, the areas under this tell us how far I'm traveling in a direction. So whatever this number is, this is how far I'm going to the right. And then whatever this number is, this is how far I'm going to the left. And then I'm going to the right, and then I'm going to the left. Well, this area, you can just visually see it, is larger than this area. So I'm going to the right a lot. I'm not going back past where I started. I'm going to the left a little bit. Then I'm going to the right a little bit less. And then I'm going to the left a little bit less. So obviously, the start is when I'm going to be furthest left because I go to the right a lot. I go back a little bit. I go to the right a little bit. I go back a little bit. Okay? Good ways to see things and make sure we understand what's going on. But that was like pretty involved. Usually on a test, you're not going to have 3 points. You're usually going to have 2. And then you have to identify maybe like one of the relative maxes and one of the endpoints, and then one of the relative mins and one of the endpoints. Average velocity, we just talked about this. Average velocity, you can take the antiderivative and find change in position over change in time. But I have a calculator. It's easy. 1 over b minus a, integral from a to b of whatever we're trying to find the average of. It's not the area under position. It's the area under velocity. I can find this by plugging this into a calculator. I already have this. I might as well just change this from 0 to 7. And then either take this and divide it by 7, or multiply it by 1/7, put a 1/7 in front of it, and you get an average velocity of 2.736 or 737, whatever, meters per second. Just put the number. I don't care about units. Okay. All right. Next 2 problems. Given the velocity, whose position t of 1 equals 3, it probably should be told that these are the areas. T of 1 is 3. Okay, so x of 1 is 3. That is like an initial position that we're given. When is the particle furthest to the left? What is its position? Explain your calculus justification. So you're going to change directions, or when it's furthest left is when you have a min position. I'm trying to explain this like with proper justification. I'll show you different ways to find this answer, but with proper justification, you're like, okay, furthest left, min position. Min position is when the derivative of position equals 0. Well, the derivative of position is velocity. Velocity is equal to 0 at 1, 3, and 5. So I got 1, 3, and 5. I'm going from 0 to 6. No, I didn't tell you I'm going to 6, but whatever. You can see I'm going to the right. This is the velocity, derivative of position, or position's increasing, then it's decreasing, then it's increasing, then it's decreasing. This is telling you how you're traveling. You can just kind of figure this out, where you start at 1. Well, when you get to a position at time 3, which will be a relative min, where are you going to be? Well, when time is 3, you've traveled 5 units to the left, starting at a position of 3, you're going to be at a position of -2. Now, when time is 5, you've traveled to the right 3 units if you started at a position of 3 at -2. So I add 3 to -2, I'm now at a position of 1. It's my location. And then at 6, I've gone to the left 2, I'm back down to -1. The question becomes like, where am I at 0? I'll show you multiple ways to define this, but like if your area is 4, wherever you started, you went to the right 4 to get to the position of 3. That means you started at a position of -1. It's like if you want to go backwards, go to the left 4. If from 0 to 1, you went to the right 4. Now you can kind of see like, where are my possible mins? Here and here. So I go to the right, I go to the left, I go to the right, I go to the left. I also could be here. X of 0 is -1. X of 3 is -2. X of 6 is -1. X of 3 wins. And you can see like these are really your only candidates. It's when I change direction or where I started. Other ways to do it is to identify your candidates and be like, okay, what is my position at time 3? Well, it's going to be my starting position, which I got at 1, plus my displacement. 1 is 3. Integral from 1 to 3 is -5. I get -2. You do the same thing, like x of 6 equals x of 1 plus the integral from 1 to 6. And you would say this is 3 plus -5 plus 3 minus 2 is -4. That's how you get -1. And then you should be checking x of 0. Now, here's how I would probably do x of 0. I'd probably say my ending is at 3, or my ending's at 1. I got the position 1, 3. My ending is at 1. My starting is at 0. My displacement from 0 to 1 is 4. I don't know where I start. How do I find x of 0? I'll subtract 4 to get that position at time 0. I go backwards. From 0 to 1, this area is telling me I'm going to the right 4. From 1 to 0, go to the left 4. It's -1. So what is the answer? Yeah, x of 3 is -2. Different ways to find that answer. Just show me that you know what you're doing in this situation. It's not super justification oriented. And then finally, average velocity from 0 to 5. Average velocity, area under velocity, not area under position, not velocity values, times 1/5. 1, 2, 3, 4, 5. Okay, so the area from 0 to 5 is -1 plus 3, which is 2, times 1/5, and you get the answer 2/5. That's it, okay? Um, do your free response problems to prepare you for your test, okay? You got to make sure you understand distance, displacement, speed, traveling right, traveling left, going towards something, going away from something, all involved. And lots of different types of questions. Practice, practice, practice. And get ready to take pictures, submit, and I'll be ready to grade it. Thanks.